Water scarcity is one of the most pressing global challenges of the 21st century. As populations increase and climate change intensifies, many nations face the daunting task of securing reliable and sustainable water supplies. Among the nations that have successfully addressed this challenge, Israel stands as a global leader. Israel is a desert country and has faced a chronic shortage of water since its establishment in 1948. However, in a remarkable turn of events, today Israel produces 20% more water than it needs. The country has not only solved its water crisis but has also become an exporter of water technologies to other nations. To achieve this, Israel embarked on one of the most ambitious water infrastructure projects in the world. This project has become a symbol of innovation and resilience. Today, let's delve into Israel's incredible water highway, examining its history, design, challenges, and global impact. Origins of the project. Believe it or not, Israel is using salty water from the Mediterranean to refill its biggest natural source of freshwater, the Sea of Galilee. The way it's being done is nothing short of incredible. The water is filtered in desalination plants across the Mediterranean coast and then transported to the Sea of Galilee in the north. Not only is this enough to solve Israel's water crisis, but it also creates a surplus that allows them to provide water to neighboring countries. To fully understand Israel's water innovation, it's important to look at its history. By the 1950s, water shortages in Israel had already reached critical levels, threatening the country's development and agriculture. The need for water management became even more urgent as waves of Jewish immigrants arrived, increasing the population and placing greater demands on natural resources. The situation required immediate and innovative solutions. In 1937, a British engineer named Walter Clay Loudermilk proposed diverting water from the Jordan River and its tributaries in the north to the arid regions of the Negev Desert in the south. Although the project was put on hold due to World War II and subsequent geopolitical tensions, the concept laid the groundwork for future developments. Following Israel's independence in 1948, the young nation began laying the foundations for a massive water infrastructure project, the National Water Carrier. This plan would transform the country's water landscape. Water was transported from the Sea of Galilee, which receives rainfall, to the southern parts of Israel, which have zero rainfall. The project required significant financial investment, but it enabled life across the country. Design and engineering. The National Water Carrier is an engineering marvel, a 130-kilometer-long system of canals, tunnels, pipelines, reservoirs, and pumping stations stretching from the Sea of Galilee in the north to the Negev Desert in the south. Construction was undertaken by Megaprojects, Israel's national water company, and began in 1953. The project involved some of the most complex and challenging civil engineering work of its time, including the construction of massive reservoirs and a network of pumps capable of transporting water across significant elevations. One of the most notable aspects of the system is its main pipeline, which includes both above-ground canals and underground pipes spanning much of the country. The system begins at a pumping station near the Sea of Galilee, where water is drawn from the lake and lifted over 200 meters above sea level using powerful pumps. From there, the water travels through a series of tunnels and canals, including the 17-kilometer-long Esh Tunnel, which was the longest water tunnel in the world at the time of its completion. The water then reaches the Esh Reservoir, where it is treated and filtered to ensure quality. From there, it continues its journey southward, descending through Israel's central plains until it reaches the Negev Desert. Along the way, various branch lines deliver water to cities, towns, and agricultural settlements. One of the key engineering challenges was maintaining the ecological balance of the Sea of Galilee. The system was designed to extract water at a rate that would not deplete the lake's natural reserves. The project was completed in June 1964 at a cost of 420 million Israeli lira, equivalent to about $1.1 billion today. Water surplus and allocation. When the national water carrier was inaugurated, 80% of its water was allocated to agriculture, and 20% was used for drinking water. Over time, as demand increased, a greater proportion was used for drinking water. By the early 1990s, the national water carrier supplied half of Israel's drinking water. The Sea of Galilee also became a strategic water source for Israel and played a role in regional diplomacy. As part of the 1994 peace agreement between Israel and Jordan, Israel initially provided 25 million cubic meters of water to Jordan annually. In 2021, this amount was doubled to 50 million cubic meters. Today, the Sea of Galilee supplies Jordan with most of its water. However, in 2017, after 5 years of drought, the water levels in the Sea of Galilee dropped to historical lows. This crisis highlighted the need for new solutions, and Israel adopted a multi-pronged approach to managing its water resources. Desalination breakthrough, refilling the Sea of Galilee. To address water shortages, Israel developed desalination plants along the Mediterranean coast. Desalination removes salts and minerals from seawater, converting it into fresh water suitable for drinking, agriculture, and industrial use. Israel's research into desalination dates back to the 1960s, but the breakthrough came in the early 2000s with the construction of the Ashkelon desalination plant, one of the world's largest at the time. Today, Israel's desalination plants produce approximately 600 million cubic meters of fresh water annually, accounting for around 80% of the country's domestic drinking water needs. In 2022, Israel took an unprecedented step by inaugurating a project to pipe desalinated water into the Sea of Galilee to maintain the lake's water levels during dry years. This was the first time in the world that desalinated water was used to replenish a natural lake. As part of the project, megaprojects constructed a 13-kilometer-long underground pipe linking the lake to infrastructure that connects to 5 desalination plants on the Mediterranean coast. The second phase of the project, expected to be completed in the coming years, will incorporate additional desalinated water from new plants and wells in northern Israel. Other technologies. Israel has not only focused on desalination but has also developed other innovative technologies to maximize water resources. One of the most important advancements is wastewater treatment and reuse. Over 90% of Israel's wastewater is treated and reused, primarily for agricultural irrigation. The Shafdan wastewater treatment plant, located near Tel Aviv, plays a crucial role in this system, treating water that is then pumped to the Negev desert for irrigation. Another major innovation is drip irrigation, a system that delivers water directly to plant roots through a network of tubes, valves, and drippers. This method minimizes water loss due to evaporation and increases efficiency, allowing farmers to use less water while maintaining high agricultural output. Future outlook. Israel continues to enhance its water conservation efforts by improving efficiency, filtration, and production capacity. The country has also formed regional agreements to ensure sustainable water management. Israeli companies like IDE Technologies, Netafim, and megaprojects are now helping other nations, including India, China, Australia, and the United States, address their own water scarcity challenges. Despite its successes, Israel still faces challenges related to water management. Climate change is expected to worsen water scarcity in the Middle East, leading to more frequent and severe droughts. Additionally, geopolitical tensions over shared water resources, such as the Jordan River, could complicate future water security. To address these challenges, Israel continues to invest in research and development, exploring new technologies such as solar-powered desalination, atmospheric water generation, and advanced wastewater treatment. By remaining at the forefront of innovation, Israel serves as a model for other nations seeking to overcome water scarcity.